So today we're going to dive into something called GRPO, which stands for Group Relative Policy Optimization. Now, this is the algorithm that's behind DeepSeek's super powerful reasoning models that are not only smart, but also incredibly efficient to train. We're going to break down what all the fuss is about and see how a really simple idea is making some huge waves.
So here's how we're going to break it all down. First, we'll talk about the big picture problem that GRPO is trying to solve. Then, we'll map out exactly where it fits into the whole AI training process. We'll get into the core concepts it's built on, explore its brilliantly simple design, and finally, we'll look at the payoff. Does it actually work?
All right, let's jump right in. First up, the high-cost AI problem. You see, to really appreciate why GRPO is such a big deal, you first have to understand one of the biggest headaches in the world of reinforcement learning. And this right here is the million-dollar question. Or maybe the billion-dollar question. Everyone, from the biggest labs to the open source community, wants to build smarter, better AI. The problem? It usually costs an absolute fortune. DeepSeek is basically saying, hey, we found a way to get that top-tier performance for way, way less. Now, the key thing to remember here is that GRPO didn't just fall out of the sky. It's actually a super clever tweak on an algorithm you might have heard of, PPO, or Proximal Policy Optimization. It's a method that's been around for a while. So GRPO is really standing on the shoulders of giants, building on decades of research, which is a huge part of its power. Okay, so to really get a handle on GRPO, we need to map out the entire training pipeline. Let's zoom out for a second and look at the standard way you build a large language model. That way, we can see exactly where this new algorithm slots into the picture. Pretty much every large language model you've ever used goes through these 3 stages. Stage 1 is pre-training. This is where it just inhales a massive chunk of the internet to learn about, well, everything. Stage 2, instruction tuning, is where we teach it how to be a useful assistant, how to follow commands. But to get from good to great, you need Stage 3, reinforcement learning. This is the magic step that lets a model get better and better using subtle feedback, not just perfectly written out examples. And even within reinforcement learning, things kind of split into 2 main flavors. You've got preference tuning, which is all about learning from what humans like. Think about when you give a thumbs up or a thumbs down to a chatbot, that's preference tuning. But then there's reasoning tuning. This is for things like math or coding where there's a clear right or wrong answer. And GRPO, it's a key player right here in this world of reason. Okay, so this brings us to a really fundamental question. How in the world does an AI actually learn by just doing things? Let's quickly break down the core ideas of reinforcement learning to see what's going on under the hood.
Now, this is where it gets really cool, because we can explain these abstract concepts with a simple Roomba. Think about it. The Roomba is the agent. Its action is to move it around. Its state is its current location in your house, and its reward, that's how much dirt it's sucked up. For a language model, it's the exact same idea. The LLM is the agent. Its action is to predict the next word. Its state is the prompt plus whatever it's written so far, and its reward, a super simple signal at the very end. Was the answer correct? Yes or no?
Both GRPO and PPO use this method called the policy gradient. The easiest way to picture this is to imagine the model's performance as a giant, foggy mountain. The goal is to get to the very top. A policy gradient algorithm is like having a compass that always points to the steepest way up from where you're standing. Every time the model gets a positive reward, every time it gets an answer right, it takes a small step in that uphill direction. It tweaks its own internal settings to say, hey, that worked. Let's do more of that in the future. And that brings us to the absolute heart of the matter, GRPO's radical simplicity. This is the secret sauce. This is how it manages to do so much by actually doing a whole lot less. So one of the biggest challenges in reinforcement learning is something called credit assignment. Let's say your goal is to make $1 billion. If you start out as Jeff Bezos, making another billion is impressive, sure, but it's not a miracle. But if you start out with nothing in your bank account, making $1 billion is legendary. The point is, your starting point, your baseline, matters a lot when you're judging how good an action was.
And this slide, wow, it just lays out the core difference brilliantly. PPO, the classic method, uses this complex approach called actor-critic. It literally trains a second AI model, the critic, whose only job is to judge the first model's actions. This is nuts. It doubles your memory usage, it doubles your compute. GRPO's solution is so much simpler, it's almost funny. It just has the model generate a handful of different answers to the same problem, and then uses the average score of that group as the baseline. That's it. One model, way less work.
Now, you might be thinking, okay, but doesn't that simple approach just fall apart or get really unstable? And that's a great question. GRPO has two clever little tricks to keep itself on the rails. First, it actually borrows a technique from PPO called clipping, which basically puts guardrails on the updates so no single change is too crazy. Second, it adds a penalty to keep the model from wandering too far away from what it originally knew. It's like a safety tether, making sure it gets smarter without forgetting everything it learned before. So we've got this beautiful, elegant, simple theory, which, of course, brings us to the most important question of all. Does this whole less is more thing actually pay off in the real world? Let's take a look at the results. Okay, so let's look at the data. This chart from the actual DeepSeek paper is fascinating. The bar on the left shows a really complex method where you give the model little rewards for every single correct step in a math problem. The bar on the right, that's the simple GRPO approach, just one reward at the very end. Did you get it right? And look at that. All that extra complexity gets you a tiny, tiny improvement. The simple approach is almost just as good for a fraction of the cost and effort. That's the whole point. And I just love this quote from the source material. It's such a great reminder that research papers can feel super intimidating, right? They're filled with all these Greek symbols and complex formulas. But sometimes, behind all that flexing, the core idea is actually incredibly simple and intuitive. It's easy to make things more complicated. It's genius to find a way to take that complexity away. And that really leaves us with this one big final thought. GRPO kind of makes you wonder, maybe the path to truly intelligent AI isn't about building bigger and more complicated systems. Maybe the real breakthroughs are going to come from finding these kinds of radically simple, elegant, and efficient solutions instead.